Okay, so this is for worksheet 8.6c for Wednesday, April 8th. So maybe this one requires a little bit of explanation. I'm sure the other ones are too easy, so I don't want to insult you by trying to explain stuff. But so this one, if you look at number one, says a parking space is marked with three-digit numbers. So that word digit numbers, it refers to the 10 number system. There's other number systems like hex system or binary system, but we know we're talking about 0 through 9, which is 10 numbers when we talk about digit numbers. Okay, so 3 digit. So we're starting from something like 000, and then we're counting how many numbers are there until you get 999. 1000 will be a 4 digit number, and like 20 will be 2 digit number, but you're starting with 000. Okay, so how many numbers are possible? The wrong answer that a lot of people will say is that there's going to be 999 numbers. Wrong. Um, because I see why people are doing that, because they're subtracting 999 minus 000, so that's 999 numbers. No. So if you try to use that logic, if you have, let's say you have number from 5 through 8. So 8 minus 5 is 3 numbers, so there must be 3 numbers between 8 and or 5 and 8, right? But if you count it 5, 6, 7, 8, there are actually 4 numbers. So it's one more than you think. So it's not just simple subtraction. So we don't just subtract to get the answer. That would be the wrong way to do it. Okay. So because of other problems on this worksheet also, we want to find the proper way to do it. I mean, for numbers, yeah, you could subtract and add one more to get how many. But what if it's letters, like from letter A through ZZ? How many are there? So in that case, you cannot just subtract ZZ minus AA, right? So the way to do it is, well, we're gonna have to fill the spaces and figure out how many numbers are possible to fill each space. So I'm gonna suggest just come up with an example first. So I gave you example something like this. So something like 073 is an example. Does not mean answer 73. Okay. So there's 3 spaces to fill. That's what example gives you. Okay, so if you just come up with one example, there are 3 spaces to fill, and the number of possible for each space is 10 numbers for the first space, 10 numbers for the second space. 0 through 9 is 10 numbers. Again, not 9 numbers. And then 1 through 9 is 9 numbers. 0 through 9 is 10 numbers. And there's 10 numbers possible for the third space. And then what do? We just simply multiply, and that gives you the answer. There are 1,000 numbers possible. Not 999, but 1,000 numbers. Okay, let's try the number 2. Now we're going to mark the space with the 3 letters. So that means you're going to start something with AAA, and then AAB, AAC, AAD, all the way up to ZZZ. Okay, so how many spaces can you mark? So example that I gave is Y and K. So again, there's 3 spaces to fill. Sometimes you're not sure how many spaces to fill. Just come up with an example of what they're trying to say, and then you should be able to tell. So there are 3 spaces to fill. And then in the first space, how many possible ways to fill the first space? Now we're talking about letters, A through Z. So there are 26 letters in an alphabet. Okay, unless you're from, cavemen, I'm sure you know there are 26 letters in A through Z. Okay, and then again, there's 26 letters. So you could repeat the same letter twice, like AA. So there should be 26 again available, then 26 again. So with the letters, you get a lot more than 1,000 possibilities. You get 17,576. That's because for numbers, there's only 10 possibilities to fill each space, but for letters, there are 26 possibilities. So you get a lot more numbers possible. Okay, So let's kind of skip down to number 5. Okay, so this time you have parking space, and it's marked by 2 letters, and the important word followed by 1 number. Okay, because can we have number first and then the letters? No, it says followed by 1 digit number. So, example PW4. Oh, by the way, please show work. Not You don't have to write down the PW4, but write down what you're multiplying, the numbers that I put underneath. So show work by writing down what you're multiplying. So what are we multiplying in the calculator? Well, 26 is a possibility for first space, times it by second space. There are 26 letters. You could use A through Z. Then third space, you cannot use A through Z now. It has to be followed by a number, so digit number. So there's only 10 possibilities. Okay, so that's what I mean by show work, 26 times 26 times 10. And then the answer, if you put it in a calculator, so 26 times 26 is 676, times 10 is 6,760. Different ways, different parking spaces. Okay, so we're assuming that you don't name same parking space with the same, twice. Okay, let's try number 30. Well, number 6. Okay, so this time parking space marked with 3 letters or numbers. So number 5 was 2 letters followed by 1 number, so it has to be letter, and a number. But this time it's 3 either letters or numbers. So in the first space you could use any letter or any number. So like example that I gave, so first space could be a 3 or first space could be a E. So do you see the difference between number 5 and 6? It's English class now. So instead of just having letters in the first space, it could be any letters or numbers in any of the 3 spaces. So first space, it's actually 36 possibilities. There are 26 letters or 10 numbers. So you could use any of those. So 26 plus 10, there's 36 possibilities. The second space, same thing, 36. Third space, same thing, 36. So you multiply those, and this is showing work right here. And then you get a little more than 6,000. You get 46,656 different parking spaces available. Okay. And then number 7, you could skip. You could do it on your own. It's just, instead of 3-letter or number system, now I have 4-letter or number system. So example, C3PO or R2D2 or R2D3, or how many of those can you get using that system? Yeah, you could do it. Okay, number 8. Now this time a package is marked with either 4 capital letters. No, wait, sorry. 4 spaces to fill, but it could be either capital letters, lowercase letters, or it could be numbers. So instead of number 6 could be letter or number. Now it's either capital letter or lowercase letter or number. Okay, so example is given right there. I'm sure you've seen this in packages or I don't know, confirmation number or something. So there are 4 spaces to fill now. Okay, so again, if you look at the example FH6F, so there has to be a 4 spaces to fill. Okay, so if you write one of the example, you can kind of tell how many numbers I have to multiply. Oh, why are we multiplying, by the way? That kind of goes back to last week, Friday's work and yesterday's work. So I'm sure you could take a look at those and figure out why we're multiplying instead of adding, because it's rows and columns and you gotta multiply to get the total number. Anyways, so now how many are possible to fill the first space with? So there are 26 capital letters, 26 lowercase letters, and 10 numbers. So altogether, you could either fill with 62 different possibilities. So I chose capital F, but it could be lowercase f, or it could be 2 or 5, or A through Z, and then another A through Z, and then another one 0 through 9. So it has to be 62 possibilities. Does that make sense? So with only the letter and number, it was 36. With capital letter, lowercase letter, and numbers, there are 26, 26, 10, there's 62 numbers and letters. Yeah. So now you multiply, show work, multiply all these. That's a lot of writing. Is there a shortcut for this? 60 to the 4th power, but you know what? Let's just write it, okay? So if you write all 4 of those numbers, it's going to be 238,000. So like imagine, packages sent through UPS or Amazon or FedEx. Well, there's millions of packages, right? So you want to have, if you only have 4 letters, 4 spaces, you could have 238 different packages. But if it's what there's more, like 2 million packages, then you don't have same name for 2 different packages. So this system, I think, would give you a lot more possibilities for naming or tagging packages instead of just using numbers. Okay, if you only use numbers, you get only 1,000 different packages. Okay, so